Hello everyone and welcome again in this new tutorial series. So today in this tutorial we will learn how to do an app of Doppelganger or the celebrity lookalike application. Okay, so let's go through. Let's start with this one. So first of all, this application or project is contained of two main phases. So as we can see here, let me activate my pen. Yeah, so this content of two main phases. So this is the main phase, or phase one is training, where we train our system. Okay, we use the CNN, the convolutional neural network, to train our system to a new person's. Then when we do the testing later on, we can recognize the person from the training model. Okay, so first training, we will, for the first phase, which is training, we will enter the image to the module, to the network, to the convolutional neural network, and we will add the identifiers or the names or any identity or anything we want to add that related to the image. Then from the training, we will come out with a model. This is the model that contains all the vectors and all the information about the trained image. For sure, we will not use only a single image, we will use few images, as we will see later. Okay, so we will come out with a model, then we use this model later in our testing. Okay, so now when we come to the phase two, which is testing, we will use any other image of the same or different person. We will send it to the network again, then we will come out with the identifier of that person or the name or whatever we have entered that related to that person, or we can display that this person is unknown, that it cannot be recognized by the system. Okay, all this with the help of the module that we already trained in the first time, or in the first phase. Okay, so let's dive in the first phase, which is the training. So from the training, for sure we cannot directly input a raw image to the convolutional network. First we have to pre-process it, convert from the BGR to RGB, align the face, because most of the images will be not aligned, as we can see here. And also we have to detect the face first, then we detect the landmarks, the points that surrounding the face details. We use this what they call DLib library to do all this, the detection of the face and the landmark detection. After that, after we detect all this information, we convert this information into a vector of 1 byte 128. Okay, and this vector, okay, with the help of this neural network, it will be clustered in one place inside the model. Okay, for example, this is already pre-trained information of persons inside the network. So when we enroll, by the way, I will talk to you later about the difference between enroll and training. So when we enroll a new person, it will be clustered again. For example, this is a new one that's not same to any of these other information, so it will be clustered. Let me change the pen color. It's black. Okay, so let's say it will be clustered here. Okay, this is a new person because not same to any other persons or any other identity we trained before. When we enter a new image, let's say this is a new image. Okay, so this new image will be, let's use which color we're not using here. Orange we already use, blue we already use, red. Let's use this dark red. Okay, let's say this is a new image. When we enter this new image, let's say it will be clustered here. Okay, so this is the clustering, that the neural network will group all the same person's information in one place. Okay, you see this? Or every new person will be clustered in one place, different from the others, that they cannot be mixed together. So this is person 1, person 2, person 3, 4, 5, etc. Okay, now I would like to highlight that we are not training the module from zero, because if you want to train the module from zero, I mean make your own brand new module, it will take very long time. It might go up to days, and also require very special care of this process. However, in this tutorial we will do enrollment. Okay, enrollment is mean we already keep the original information, but we will add on our new information. Okay, the old information sorry, we will maintain. We will add our own new information module. Okay, so it means we already have the module, but we will add on the new information. Okay, so with that, let's go and dive in the coding and see how we can complete this task of training in the Python by using the dlib and the convolutional neural network. So, okay guys, welcome again. So I will start with the training code. I will develop the code in the PyCharm environment. Okay, so as you can see here in the code repository, I have already included the images that I will train my model, or I enrolled in the model. I have few thousand of images, about 2,000 folder plus. Each folder got some image of different celebrities, about 5 images, okay, of different celebrities. Let's try this. As we can see here, okay, so we will train all these images into our module. Later I will share the link where you can get all these images from the online. Okay, there's a lot of images online, a lot of places online that provide such images for neural network training. And also I have the names, the names. This is the celebrity mapping name. This is the names of the celebrity. But again, we will enroll it into the neural network. As we say, we need the images and the names, and then we have the ResNet model. This the ResNet model is the how can I say, is the original one, or the trained model that we will enroll the extra images inside this module. And also we have some testing image. We will use these images for testing. This one, this one, this one, this one. We will use it for testing later. Okay, so the idea here, we are not testing the image. I mean, we will use the system to identify the person. Okay, for example, this for the Sophia Solaris. We will not enter this image to get the Sophia Solaris, because I don't think we have all the celebrities inside this celebrity mini, but we will get the closest person that look like her, and we will see who is it, who is he or she. Okay, same goes, for example, for this picture. Is not celebrity yet, but so we are not training it in the celebrity mini, so we see which one is close to her, and etc. Okay, so let's start. And for sure we need the landmark predictor and the dlib detector along the way. So we will start to develop the code now. We will make new Python file. Let's call it training. Okay, so now let's include the library and the required libraries or libs. So the first library we want to import it is the OS, because we need to add a lot of we need to join a lot of paths. We find the path to each image, etc. So we need the OS, and we need the globe and also random. What else? We need to import dlib for sure. We need to import cv2. We need to import pickle, this to save our train model. Pickle as c. Pickle. What else? What else? For sure. Import numpy as np. Import time, and we need to import matplotlib. Plotlib.py. Okay, so now we finish the importing. Okay, now let's see. First, we need to load our model for the dlib. Okay, we'll use the 68 module, 68 landmark. So now, I'm sorry. So here we are loading the dlib. What I call the dlib model file. Okay, so we need the predictor path, and also we need the face recognition path. Okay, so for the predictor path, we will use this one, as we say, the 68. So let me copy this, copy path. I guess copy path, copy file name is equal to here. And also for the recognition, we will use the ResNet. Copy path, copy name. Okay, there we go. Okay, let's test out and see if we done everything correctly. We got an error. No module globe. Why no module globe? Do we need to install this one? Let's see. Okay. We need globe. Yeah. Install. Okay, while it's installing the package, let's move on. Done. Okay, good. The globe is already done. Let's see what else. I believe is the matplotlib. Matplotlib. Yes. Install. Okay, while it's installing, let's continue with our code. So what else we need? We need to initialize the face detector and the face landmark predictor. Okay, so we have face underscore detect equal to dlib dot get frontal face detector. Yes. Then we have, okay, good. It's already package installed. This is why we still have the error. Okay, good. Okay, good. We have installed all the required libraries. Now we are good. We have no any errors code. So let's move on. So we have already declared the face detector. Now we have the shape underscore predicts equal to dlib the shape predictor, and shape predictor we need add the landmark detector or the landmark predictor path, which is here. Need to add the predictor path. Yes. What else? We need to declare or initialize the face underscore recognize and face recognize equal to dlib dot face recognize model v1, and also we need to add the face recognition path. Face this is capital face recognition path. Okay, so here we are good. Let's try. No errors, all looks happy. Here it takes some time because it's loading these two model files. Okay, now we will add the images data. So we have the root to the celebrity images. So we have face data folder equal to this one. So we copy the path, copy the name. Okay, so this is the path for the for the name. Sorry, path for the data for the images, and then we need to declare the label map. Label map equal to np dot we load what? We load this the celebrity mapping. We load the celebrity mapping dot npy, and we allow underscore picker convert it to item. Okay, so include all our data now that we will work on. So let's try again. It's good to try every now and then. Okay, good. So now we need to we find the subfolders. We find the subfolder inside each file. Inside each, yeah. We just like go through these subfolders inside the main folder, which is the celebrity main. Okay, so we have to declare the subfolders equal os dot list dictionary of face data folder. Okay, so we convert this into a list, every subfolder inside the main folder. Okay, that's good. So now we go to loop through the subfolders. So for each folder, okay, in the subfolder, okay, so we go loop through each folder inside the subfolder. What we will do now, we will declare the celebrity name. Celebrity name is equal to label map of the same folder. Okay, because we take the name of the same, the path, because this label map is a range that match the first name that's stored inside the celebrity mapping is matched the first folder, second name, second folder, and etc. So we just take the name of that folder with the name of the first folder. So it helps us later to display. So here we find the celebrity name that match that folder. Okay. And what else? Then now we load the images in that folder. Okay, so the image files in that folder equal to os, again list dictionary, because a directory, sorry, not dictionary, list directory, because again you see here we explore the directory that inside the celebrity, this directory. Now we list the directory that inside the subfolder. You see, this one is a sub of the main. Now this one is a sub of the sub. Okay, so os dot path dot join. So we have the face data folder, and we will join it with the folder. Okay, that's good. So now in here we have the directory of all the sub images inside the subfolder. So again, we have to go through them again for each. Let's say file now. Actually, it's an image. Let's say a file. In the image files, so we go each image inside this file. We do what? Find the full path for each image. So the full path is equal os dot path dot join. We join what? We join the face. You see, this is the face is the main. Okay, the celebrity mini. We join it with the folder, with this subfolder here. Then we join with what? With the name of the image itself. Okay, with the name of the image itself, which is file. Okay, and this one of course should be here, should be indent here. Okay, again, so this common here, we join the face data folder. If you see here, the face is the main. This is the main folder. We join it with the subfolder. This subfolder we already find here. Folder is part of the subfolders, which is this one of these, plus the file name, which is one of the images that inside the subfolder. So now after we go through this, and we reach, so now the full path is the image path of each one of these. So what to do now? We just read it. Image equal to cv2 dot im read, and we read from where? From the full path. Okay, that's all. So now we read every individual image inside the subfolder. Okay, so now we can display. Let's display the images for testing. So here we can display for testing. So we use the plt dot I am sure. I'm not sure if this one works here. I never tested before. That I am sure, and then we display the image. Okay, and then we need the plt dot show. Let's try. Hopefully, if everything okay, we can see the celebrity images start from the first one. It will be this. Here we go. Oh, but why? Yes, you see now. Here, as I said, every celebrity file got 1, 2, 3, 4, 5 images. 4, 5. Now it should go to another one. Here we go. 2, 3, 4, 5. Here we go. Go another one. But let's see why this one. I guess here we need to add another different channel. So 1, 2. Yeah, I guess convert from BGR. Yeah, more nicer. Okay, so 1, 2, 3, 4, 5, different one. 1, 2, 3, 4. So you can see here we are go through each individual image inside the subfolder, inside the main folder. Okay. Good. Nice. So now let's move on. So since we're able to read and show the image, now what we want to do, we want to detect the face. Detect the face of each image. Okay, so the faces equal to face detector or face detect equal to CV2. First, actually, we have to convert from the BGR to RGB because the DLib, we're working with it now, it's work with the RGB, so we have to convert CV2 dot CVT color to convert the image, CV2 dot color BGR to RGB. Okay, so now we detect the face for the RGB image. So now actually we can see by print out the faces. Let's see what we will get. We can see that the rectangular of the face will be displayed here if we successfully have to close. Okay, here's the first rectangle, second rectangle, correct. Okay, good, no need to continue now. So this all okay. So now as we detect correctly the faces of each one, so we have to go through each face. We have to look through each face and predict the landmarks. Okay, so for any counter and face in the faces, enumerate faces. Okay, so first we will do what? We will find the landmark. Oh, okay, before the landmark, we will find the shape. We use the shape predictor. What is the shape predictor here? Okay. Then we send to the landmark. To find the landmark, yes, we find the landmark. Okay, so how to find the landmark? Okay, so we say shape equal to shape predict. This to predict the landmark. Again, we convert CV2 dot CVT color image, CV2 dot color BGR to RGB, BGR to RGB. Okay, so here we find the landmark. Then we need to convert the landmark from the delete to XY list format. So the landmarks equal to convert it into a list P of X, P of Y, for P in shape of parts. I guess here part should be capital. No. Okay. So here we already calculate the landmarks. Let's print out the landmarks. Let's see if we are correctly coded. Print landmarks. Run again. So now we can see all the 68 landmarks. Okay, close. And is it here? Why we go on the shape predictor? We need the faces here. We forgot to pass the face because we need the image and the face to find the landmark. Yep. Sorry, there's a mistake here. Here we go. This is our rectangle. This is the faces, and this is the landmarks. It's all the landmarks. Good. Okay. So landmarks successfully done. So after we find the landmarks, we do what? After we find the landmarks, everything okay? We have to compute the face descriptor. Okay? Using the neural network. That in the delete. Okay? That we found it in the delete, and then we convert it into the that generates the 128 D vector. That describe the face. Sorry. Okay. So now face descriptor equal to face recognize. We recognize the face and we compute the face descriptor. Okay. And here we have to pass the image and the shape, or the what they call the landmarks that we calculate just now. Then we have to convert the faces descriptor from dlib format to list. So how we convert it into a list? We have face descriptor list equal to x for x and face descriptor. Now convert to an NumPy array. So face descriptor not list will be array np dot as array. We take the face descriptor list and also take the other argument is the type. The type equal to NumPy. It will be float 64. Okay. Float 64, then face descriptor array will be face descriptor array NumPy dot new x's. I'm sorry. Okay. So now, after we convert everything into NumPy array, we can display and see. We can print the face descriptor array. Let's test again. Okay. Here we go. Beautiful. So here we can see this is the rectangle of the face detector predicting the landmarks here, and this is the vector that we convert into an array. Okay, good. Let's continue. So next we are stacking the face descriptors, which they are 1 by 128 of each image. So now we need a face descriptor. Do we need a face descriptor here? Let's see if face descriptor will be face descriptor is none. I believe it should be capital. if it's none, so the face descriptors face descriptors is equal to face descriptor array. But here, face descriptor. This one, I believe we need to define it somewhere here. Face descriptor, the first of all should be face descriptors. Why is it not saying? Okay. Else face descriptors equal to numpy dot concatenate. We will concatenate. Sorry. The face descriptors we will concatenate the old face descriptors. This is the old face descriptor with a new array. And the x is 0. Okay, and now what else? So now we have finished the descriptors. This one will add all the descriptors. I mean the face descriptor, we will concatenate it together. Now we left with the with the celebrity names. We need to now index and go through the celebrity names. Maybe here. So look through the celebrity names and save them. For the future use. Okay, so now we need an array. Let's go and define an array somewhere with the descriptors. Yes, so we need the index equal empty array, and also need the count equal to 0. So later I'll use this to save my I'll save my celebrity name. So index of I because I already start from 0 equal to celebrity name, because here we already find the celebrity name. If you remember, somewhere here the celebrity name equal the lab map of that folder, and each folder got 5 photos, so we go through already. And then now we need to increase the I by 1. So I plus equal 1. So now should be okay. What we want to do now? So we already describe, add all the descriptors. Okay, let's print the descriptors. So after here, we print descriptors. Also face descriptors. Let's see how they looks like. So now if you can see, the descriptor will be only 1. See, this is only one. The descriptors will be concatenated for each picture or image. Let's see how. Okay, so this is one. There we go. So calculate only for one. Oh yeah, we can see now it's add on. Sorry, so this is the first one, it's the second one, the third one, fourth, fifth, etc. If we go more, yeah, you see it's add on. Okay, good. So now we move on. After we complete this all, now it's time to what? Time to what? I guess here it's time to let's save. Here we save the updated new model to our local drive. So np.save. We save what? We save the descriptors. This is our new name. Dot npy. Yeah, descriptors.npy. This one should be here. We will store it. We store inside this. This is the name, descriptors. We will store inside it the face descriptors. And then we store the celebrity indexes. Okay, so we use with open index dot picker what is that? It's annoying. Then we use WB as F. Then we say C picker dot dump. We save the index as F. Okay. So here, okay, everything okay. We right here. So we save as index pkl. Okay, this all correct. As F and okay. Should be okay now. Let's try. So here, after to save, I would like to display the training is done. So I just print training done successfully. Okay. So again, as we can see here, but now to make our training fast, we don't need to go through one by one, then we click, then it will be too slow because there are thousands, a dozen thousands of photos. So first of all, here, celebrity image, we don't need to show the image. We need to print the face image or the face, all the print, we don't need it, landmark, descriptors, but we need to add, here also we don't need, but we need to print maybe here. So after each loop is mean we finish one file inside the subfolder, sorry, one folder inside the subfolder, or one subfolder inside the main folder of each of this loop. So yeah, here, so we print celebrity name is trained dot format. We need the celeb name. Okay, let's try again. So now we will not see any. Here we go. So this one's already trained. 1, 2, 3, 4, 5 done. 1, 2, 3, 4, 5. Okay, beautiful. Now it's training. So after it will be concatenate, finish all the training here, then concatenate all the faces. Okay, then it will come here to save the new model. Then it will print train done successfully, and we will see here in our folder, or the main project folder, that we have two new model files, which is the descriptors and the index. Okay. Okay, guys, so I guess I'll try to pause the recording now, because this one might take a few minutes to an hour. So I'll see you later when it's finished. Okay, guys, so as we can see here, the training done successfully. And we can see here, we train all the pictures in the folders and the subfolders. Okay, and we can see here, we have the descriptors, the NPY, the new model, and also the index that contain the names of the celebrities that follow the sequence of the pictures. Okay, so we have generated these two models. So if we go again to review our code, so first we declare all the required libraries. Then this is the path to the dlib model files. And here we initiate the dlib detector, predictor, and recognizer. Okay, then we define the root directory to the pictures and the names. Sorry. Then we go through each folder in the subfolder. Okay. Then we go through every image in the subfolder. Okay. Then we go through each individual image. We read it. Then we convert from BGR, because the CV2 will read the image as a BGR. We convert to RGB. Okay. Then we detect the face first. Then from the face, after we detect the face, we detect the landmarks. Okay. Then from the landmark, we generate the vector, the 128 vector. Okay. Then we convert it into a list format. Then we convert it into an array. Then this vector, we cascade it in the face descriptors. Okay, we stack it, sorry, not cascade, we stack it. Okay, and then we also stack the celebrity name in the index. Then after that, we save the module that we generate from the descriptors in the descriptors.npy, and also we save the name of the celebrities in the index.pkl. Okay, we see here it's already trained and finished with success after about 3 hours. Actually less than 3 hours, 2.5. So train finished successfully, and also we have generated these 2 files, descriptors.npy and index, that we will use this in the testing phase. So far I believe this is all for this tutorial, as it takes too long time, almost 1 hour. So I guess we cannot proceed with the testing here. So we will do the testing in the next tutorial. So I hope you have learned something from this tutorial. Thank you very much for your listening, and please let me know if you have any comments or any questions. Thank you very much, and see you soon.